A little bit about me. I'm the CEO of Corgia. We are breeding attack dogs that are corgis for physical security. Great. Our biggest customer, the Queen, unfortunately, who had a lot of corgis. No, I'm joking. We're building an AI appsec engineer that helps find, triage, and fix insecure code. So that every developer gets their own appsec person, because the ratio between appsec leaders and appsec engineers and software developers at most companies is 1 to 100 if you're lucky. More like 1 to 200 or 300. I'm seeing a few nods around the room. It looks like many of you might be in that situation. Third-time founder, sold my last startup to Coupa. I used to lead the payments product and own the security and fraud and compliance for that product. And so, whenever you're moving money, you get mosquitoes who are trying to intercept those payments. And so we've been very lucky to have pioneered a lot of stuff in security for payments, which is when I realized a lot of security tools are really difficult to use and don't actually deliver on the meaningful value, which is why we started the company. I love GIFs. This whole presentation is probably one giant GIF. So I hope this is entertaining. So what to expect from this is it'll be a little high level, a little medium level, and actually we'll get really deep into code and kind of transcend how these things look like for developers, right? Because security folks, sometimes we like to talk about these things on a very high level, but let's actually see what it really means for the developer and the pain that they face. So this is about empathy. But there's 3 main problems in security we're trying to tackle, and this is a universal problem every single company we've spoken to. Massive risk blind spots, like research shows roughly 60% of vulnerabilities go undetected. And this is mainly about SaaS, right? So you have massive blind spots as a security team, and proof of that is you run pen tests, you run DAST, you run a bug bounty program, or you find out after you get breached, right? And that's where you find your blind spots. The other one is lots of noise. Tons and tons of findings. Roughly 50% of findings, what we've seen from companies we work with, are just false positive. And so you might be wondering, okay, how can we reduce that? And I'll talk about that. And developers are spinning their wheels. Now, why do we highlight these first 2 and then we talk about developers are spinning our wheels? Is fundamentally it's very difficult for developers to fix things, but also if you're generating a lot of noise and you're missing a lot of stuff, what does that do to dev trust, right? And all of this leads to an increased breach risk, massive inefficiencies, and a broken marriage between application security and development. Who here is in a broken marriage with their development team?
Who is it?
Oh yeah, maybe it's easier to say that. But yeah, I see a lot of hands popped up, and it's understandable, right? And so unfortunately, this is what it's come to today. And I think all of you here today are interested in how to mend this relationship, and we found we're becoming therapists, unfortunately. But aside from that, it's also costly, right? This broken marriage is very expensive. The average breach costs, this $10 million. Also, what's not talked about is remediation is very costly. It's like $400 to $4,000. This is a 2009 study about web applications. We were talking to a company. They calculated that remediating something in production was in the tens of thousands. I don't want to share the number specifically, but it was in the tens of thousands for them. So it's expensive, and non-compliance is becoming expensive. And I'm sure you guys have caught the Cyber Resilience Act stuff that's coming out, or CRA, and now regulation will have teeth, right? And so what do you do about it, right? First problem is the false negative problem, right? And why do we see false negatives? Like, let's understand the history of why a lot of the scanners are missing things, right? What is being missed today and why? Well, if we talk about this, and I'm talking false negatives in the context of first-party code or SaaS, right? That's our expertise. That's what I can talk about confidently. Don't ask me anything else. I know nothing about any other thing in life. But typically, CWE-based vulnerabilities are being overlooked, and code and business logic flaws as well. Right? Code and business logic flaws are immensely hard to detect. Why? Historically, most scanners are using regex and pattern-based detections, or keyword detection, which means poor rules or poorly written code leads to a lot of false negatives. It doesn't match the rule, because the rule is written in a specific way, which means A lot of teams are like, oh, let's start writing rules and fine-tuning rules and all of this kind of stuff. But when you talk to an enterprise with 5,000, 10,000, 50,000 repos in every programming language underneath the sun, that gets exhausting very quickly, right? And then the other most important part, and there's a bridge to this point, context is everything in security. Context, 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 and regex has no context, right? And I'll show you contextual vulnerabilities that we're starting to see now. Oh, this one, I shouldn't have put that one. But like in these 4 lines of code, what's the vulnerability here, right? It's session expiration. There's no session expiration. This is a logout function, right? But we're not actually expiring the session. 4 lines of code. I posted this on LinkedIn. 80% of developers got it wrong in security teams. 4 lines. Because it's easy to spot something that exists and you can look at it, like in SQL and Java. You look at the SQL query and you're like, oh, there it is. But this is actually something that's missing in the code. And we've been able to detect these things with LLMs because LLMs understand context, right? This one's even more interesting. This is actually one of the vulnerable applications on Ruby from OWASP. What's the vulnerability here? This one's a bit more complicated. This is the user's controller in Ruby, right? For anyone who is looking at this, you're updating something here. And one of the things that you're updating is the password of the user, right? You allow someone to update the password of the user. Most scanners today can't detect this. Why? Is because there's nothing to detect. There's missing lines that need to be here to actually detect something. And the context here is immensely important. And the vulnerability here is actually the code has a weak password recovery mechanism, making it easy for attackers to get unauthorized access to accounts. There's actually no update requirements or minimum password requirements being set here. So you see why I'm talking about this isn't a keyword search or a pattern problem. That's what we've been using and that's what the tools existed. This is a context problem and a code logic problem. Is everyone with me so far or have I lost people? I see a bunch of nods. Looks like people have been burnt by a few things like this before. But any questions about this?
Wouldn't this be caught by a good unit test case where someone is checking that the password should follow whatever is my password policy? Like this is a password policy and you're writing an IAM, this is something from the IAM space and
100%.
your unit test case is something like that.
Correct. So now we're dependent on humans to know that, to understand that, and for the developer to have had a product manager tell them, hey, think about these use cases, and for the developer to be like, I need to think about these use cases, and then the QE person is, I need to think about these use cases, and to have actually tested for them. A lot of the companies we talk to have really poor test cases. Test case generation is actually a really problem. You probably have seen 20, 30 startups in the last 6 months will generate your unit tests for you, right? Because it's actually a pretty big problem. But correct, humans are currently, or were currently, now things have changed, were currently the line of defense. And so this one, and what can you do about this? So we talked about this false negative problem, right? What can you do about it today? So one part of it is you put an appsec engineer to do code reviews, right? Or you put someone with a security expertise or a security champion to sit on the wire looking at everything. Unfortunately, that's not scalable because we talked again 1 to 100. So imagine 100 software engineers are producing PRs, right? That poor AppSec engineer needs to go review them. That's not scalable. And that's where security champion programs are pretty effective. Another way is you write and fine tune your SaaS rules, right? We meet a bunch of companies that have hired an army of people who are writing SemGrep rules or defining things in check marks. That works to a certain extent, but not for these types of vulnerabilities. It will catch more pattern-based stuff rather than code logic or business logic type vulnerabilities, right? So there's a limit to this. And then it's about pen test, DAST, bug bounty, or you get breached, is how you eventually find out about these types of vulnerabilities. These are still needed. I'm not saying these will ever go away, but that's why you do these things, right? And finally, AI can actually find these undetectable things now. We have done a lot of tests and seen some amazing results of things that we did. Obviously, we offer some of this. I don't want to go into that. This is not the point of this conversation. But we are seeing AI becoming very good at doing a human-like review, right? where it can come at the time of CI/CD and actually look at the code and tell you that this vulnerability that I shared is actually found by AI. And this actual explanation is actually explained by AI. I never wrote any of this. This vulnerability was also found by AI.
Are you finding code generation is avoiding these problems in the first place?
So the question was, are we finding code generation is avoiding these problems in the first place? Unfortunately not. Research has shown that code gen is actually producing more insecure code because it's trained on average code, right? The other thing is, most people don't actually understand how code gen works in Copilot. Because we're building on AI, I'll actually maybe shed a little bit of light on this, because this might actually be quite informative for a lot of folks. The whole point of systems like Copilot and all of these code gen systems in IDE is to be blazing fast and helpful. The problem is you have milliseconds or maybe a second or two to guess what the developer wants to do next, which means you have to limit the context window you pass into the LLM. They also have a really crazy cost problem because of this. It costs Microsoft and GitLab and a lot of these tools a ton of money because you're constantly running queries every few seconds to actually guess what the developer is trying to do next. So what they do is they limit the context window, which means you're actually not capturing the fullest nuances. Who's used Copilot here to code in any way, shape, or form, right? It vomits out certain code, and you're like, you're missing the context here completely on what I'm trying to do. And it's getting better. It's getting better, but it doesn't have the full context of what you're trying to do. And so they're trying to balance accuracy, speed, and cost effectiveness, right? And so that's why we see code gen actually be kind of bad at doing things securely. Go ahead.
So can I ask a follow-up?
Yeah.
You're suggesting code gen is not avoiding the problem, but AI is to solve the problem?
Correct. So it turns out when you instruct AI to help you kind of do things, you're not actually trying to instruct it to do things securely. And it also doesn't understand your full security context. What we've done on our side, and I'll tell you, is we've instructed it really heavily to focus on security. And then we've also fine-tuned LLMs to focus on security. So now we've cherry-picked and trained it on, here are great fixes and how you fix insecure code. It can be very good at fixing insecure code, right? And it can actually outperform what a developer can do and actually implement best practice, right? Unfortunately, when you're doing generic code gen, it's trying to guess, I actually did the math on this, it's roughly 300 million permutations. Like, think about that, right? If you have a few thousand enterprises building a few hundred features and developers are like literally hitting it every few seconds, you're trying to guess 300 million different permutations of what a developer can do. So it's not optimized for security, but if you get it to focus on security, it can do wonderful things. So it's an interesting thought, right? Anything else before I move on to the next problem? False positives, everyone's favorite topic. Who here struggles with false positive? Yeah, almost everyone in the room. Who doesn't struggle with false positives? Actually, I'm curious now who doesn't. Yeah, not a single hand, right? So, not to shit on Sneak, I think this is just a universal thing. This was a Reddit comment that I saw on some DevOps subreddit. We use Sneak in our pipeline and it reports so much stuff the dev said, fuck it, and allows set failure to true so that we can continue to do builds. Sneak concerns get filed away into tech debt. No one intends to pay it down. Right? And why is that? This is what we're calling the cyclone of debate that's happening. Your SaaS scanner finds something, it lobs over the vulnerability to the engineer, the developer complains about it being a false positive, developer reviews it, determines if it's legit, and now the cyclone of debate starts to happen, right? Who's been in the cyclone of debate? Yeah. How many hours of your life have you lost to the cyclone of debate? Too many. We hear about half-hour, 45-minute meetings about a single vulnerability. Is this exploitable? Is this true? Is this framework supporting this or that? And it's all kinds of questions and crap. And the developer has every right to because they've been burnt, right? 30 to 50% of the fines, like 1 in 3 to 1 in 5 is just wrong. So they're going to complain about it. So One of the co-founders of Rapid7 explained this concept, and I loved this. It's the human crumple zones. And what's happened today is the tools are running people, rather than the people running the tools. And so you have a choice of one of three crumple zones in your company. The first crumple zone is your security team being the triaging for false positives. They're taking the impact of all of that, and they're dealing with it, and they're the human crumple zone. This is the first thing most security teams try. And they realize very quickly that they can't do it. Then they pass it on to the second crumple zone, right? The dev team. And the dev team now gets the impact of all of this, like false positives. And then for some companies that give up and declare bankruptcy on this, it becomes their security posture as the crumple zone. Neither security nor dev nor anyone is actually handling this anymore, and security's gone out the door, and the security posture is now the crumple zone. Which one is your crumple zone?
It's the dev, right? It's always the devs. Security can't do it, they got a tool over the wall to the devs.
So now we have human crumple zones of devs where the SaaS scanner is running the devs, and the devs are like, I'm tired. So the empathy there for the devs is real, right? Like the developers are struggling with these types of vulnerabilities. And so what's being flagged and why? Well, everything. We are seeing patterns, and I actually have raw data on this, and it's actually pretty interesting, and I'll show it in a second. But why is this happening? Again, we come back to the keyword and pattern-based detection. Poor rules or poor code lead to false positives. Actually, this should say positives. I copy-pasted shit. Scanner companies also don't want to miss a vulnerability. In their eyes, it's better to over-report than under-report. I think there is this race to how much you could find. And this was driven by security teams, unfortunately. I'll blame you guys. You did POCs. In the POCs, you're like, we're going to put all these three guys against each other, or three, security tools. And then you go to them, you missed this one. And then they're like, hey, we need to find everything. And they did, and they found a lot of false positives. And so I think this was unfortunately the trend at the time. How much can you find? And I think now it's about what's the right stuff that you can find. And we constantly ask this question at the company, what is the gold nugget, right? What is the nuggets of security that we need to share? Because honestly, not everyone has the bandwidth to solve everything. So what are those nuggets, right? And again, it also falls to lack of context, right? Context is immensely important, and I'm actually going to show real code examples around this. But before I do that, this is actually we have our own test harness that tests Corgia's performance. And one of the things that we've seen is do certain programming languages behave better than other programming languages? And do certain scanners perform better in certain programming languages? Because we kind of want to get an idea of what's going on, and you do see big variances depending on your programming language and framework and implementation as to this. What's in orange is false positive. We use our false positive detection to actually generate this data. This is a real screenshot from our BI tool. And you can see in this C# set of applications, and these are thousands of vulnerabilities. You can see in JavaScript, this is roughly 2,500 vulnerabilities, right? It's actually not a small amount. And you can see roughly 30% in JavaScript. Why? Because JavaScript and TypeScript have become the wild, wild west of programming languages. The NPM ecosystem is massive, and you're moving from ES5 to ES6, and there's so many ways things are built, and it's a dynamically typed language, right? So there's struggles with JavaScript, TypeScript. We had one dev manager had 45% false positives on their JavaScript, TypeScript application, right? And so you start to look, how good is the scanner? How good is the language? How good is the code that we're writing? How good are the rules? And it starts to actually vary quite a bit. So even when you go talk to your own dev teams, you'll notice the people working on Go, because it's so standardized and so low level, actually experience a very different experience in security than the people who are experiencing maybe the C# or JavaScript, TypeScript type application. Is this an interesting slide, by the way, and just showing the nuances of this? Okay. So this is a great example. This is a Django application with CSRF exempt. Can everyone agree doing CSRF exempt here is a bad thing? right? You see that. It's like highlighting line 17, CSRF exempt, naughty developer, you shouldn't do that, right? Because that word fell on Santa's naughty list. But the reality of it is a false positive because it's not directly exposed to the user, requires authentication, as you can see here. Additionally, the code checks for valid input and performs server-side logic, which mitigates CSRF. The CSRF decorator is likely used to enable API functionality, and we see that in the JSON response. You see the failure of keyword and pattern-based searches? We looked for @CSRF exempt, but the context is important. This is API functionality, and it's actually doing a lot of restriction on what the person can do with this. 90% of Django applications, including we build on Django, do the CSRF exempt because we're building APIs. Any questions about this example? Is this a good example to kind of highlight why you see so much noise? Another really cool example, hard-coded credentials. I see Matt rolled his eyes. How many hard-coded credential vulnerabilities do your systems find? This is a valid hard-coded credential detection. It's valid, look at it. It says password equals this. Naughty developer, you shouldn't have done that. Why is this a false positive? Because it's a test case. It's a benign credential. Again, context is everything in security. This being here versus this being in your business logic are fundamentally different vulnerabilities. This is not a vulnerability. Right? So imagine you're a developer and you see these things. How do you feel? These tools are dumb, and developers are also like, I can build something better. Right? Developers love to shit on technical things, and they're like, I can always build something better. And so before I go into what you can do about it, any questions or thoughts or commentary? I'm either doing a great job or a terrible job.
Good job.
Thank you. How often do you folks see these types of things and these arguments with developers, right? So what can you do about it, right? Again, you put your security team on triage on all things, human crumple zones. I don't think any security team in this room is probably doing that, although I did meet one recently that has like 25 people in India that's writing SEMGREP rules and triaging these things, yeah. Some people are doing that, and it's costly, it's expensive, and you write and fine-tune your own SaaS rules, lots of work. I don't know any Fortune 1000 that's actually able to control this problem. And then you can use AI to auto-triage the findings. So the examples I gave were detected by AI. These are not things I've written. These are things AI has been able to do very, very accurately. And then the final problem, the fix-it problem. And we have a lot of thoughts about this. If I asked any of you, how do you solve an SQL injection? You're going to tell me one of two things. You either parameterize the query or use a prepare statement, right? I'm seeing a lot of nods. You go ask every developer, they're like, yeah, I did my secure code training. We did OWASP top 10. I aced it. We did the parameterized query shit. We did the SQL prepared statements shit. I'm good, right? In reality, there's 40 different ways to solve SQL injection. Who knows why? I gave you 2, but why are there 40?
There's an unlimited amount of ways to solve any problem.
It's actually a programming language, framework problem, database problem, and database connector problem. That's the interesting part as we kind of dug into it. Like, here's a real example of this. This is a Django application that has a raw query, but it turns out actually someone had created a login object. And all they needed to do was use the native Django ORM. So it's converting what was there in raw SQL into Django ORM native functionality, right? Because it's using Django, Python, and it's an ORM-based application, you can do that natively. You don't have to write a raw SQL query, right? That's one way to solve SQL injection with this combination of things. Another way is, this is same thing, Python, raw SQL query, but it's also not using an ORM. So now you have to actually fix it differently. So while the developer understands the concept of fixing and how to fix something, when it comes to brass tacks, they'll have to Google it, go to Stack Overflow, ask ChatGPT, look at the scanner examples, and actually try to map their context of the language, the framework, the implementation, how it's done, and the logic to what's doing. They're doing one of the two things I mentioned. But the permutations are indefinite in a lot of these scenarios. This is a C# application, completely different way. So most developers are working on what, 3 to 5 different programming languages and frameworks? There's 900 different CWEs. Even if you were to take, the OWASP top 10, you're like looking at probably 50 to 100 permutations that they'll encounter in a year. And so it's very hard for them to natively know this. Right? This is a Ruby one, completely different way of doing it. So that's why they're Googling, they're asking you, give me examples, how do I fix this, how do I do this? How many times have you gotten developers that reach out to you, how do I actually fix this? Right? I see a lot of people nodding is because their job is hard, right? I always say this, like, developers are expected to perform high quality, feature-rich, performant, secure, bug-free code. If you know anyone that can do that, we're hiring. And so they end up in what we call here vulnerability hell, which is the cyclone of fixing. So we had the cyclone of debate. This is the cyclone of fixing for the developer, and it's actually much more nuanced than this. The cyclone of fixing for the developer is the developer now spends time researching the issue in ChatGPT, Google, Stack Overflow, SAS Scanner example advice. They try and develop it, they create a PR. The unfortunate thing, they open the PR and it's a false positive. The scanner runs, telling them telling them that it's a vulnerability, but it's actually a false positive. And that poor developer's like, I thought I fixed the problem. In reality, they may have fixed it, and so they go back. They attempt again. And they end up in the cyclone of fixing until they get fed up and they go to the security team and they're like, I don't know how to fix this, what's going on? And the security team's like, yeah, this is a false positive. Who's experienced this exact cyclone with the developer? Yeah, seeing a few hands come up. And so the developer problem isn't just about fixing, but they're also receiving bad feedback. And that's painful because now you're being gaslit. Right? This is the gaslighting of developers. They're like, but I fixed it. And now it's like, no, it's showing up again. And it's like this never-ending cycle, right? And so this is how I think most developers look like when they're trying to fix things. So what can you do about it? Don't shit left, shift left. And I think shift left has become a term that's been dirty and has become really shit left. And sorry, I don't know if I can cuss in these. I know these are recorded. So, but most things about shift left, we're going to put a scanner into CI/CD pipeline. We're going to give you secure dev training. Good luck. In my opinion, that's shit left. Because what you really need to do is developer training, a security champions program. AI can now help assist developers in fixing these things. And we need to give developers the most amount of assistance. AppSec teams can't do it, they're overwhelmed, right? And the final thing is, actually, this is probably, actually talking to a few folks outside this, and I added this last line after realizing it was missing. Giving developers choice. Dev experience is everything. I think most shift left programs are designed by security teams without the dev experience in mind. Dev experience is a UI UX problem, not a process problem. You really need to think about the UI UX of the developer experience, right? Where do developers want to fix stuff and how, right? Even within our own product, we decided we're going to offer IDE extensions, CLI, CI/CD, and a web app. Because when we interviewed developers, there was a cohort of developers that told us, I want IDE plugins. There was a cohort of developers that said, I want to use a web app. And there's a cohort of developers that said, I want CLI. And some developers were like, catch me at the time of a pull request. And devs are opinionated. Everyone knows this. I'd like to be the opinionated company that convinces all developers this is the right way to do it. We have tried. And we just came to the realization, you are coming into someone's workflow that they have gotten used to. Developers think about what they do as a craft. Don't mess with someone's craft, right? Developers are very proud of their work. They love writing beautiful quality code. Well, we've even realized how you explain what you're doing to developers is unfortunately incorrect from a security side. The security space loves acronyms and sophisticated terminology that really developers don't understand. Like I posted something on Hacker News recently, and someone said, SAST is a fancy enterprise term for a security linter. It is. It's a security linter. Why aren't we explaining this stuff to developers as we are implementing a security linter for you? Why do we explain security as a security problem, not a code quality problem? Developers care about code quality, right? Even the lingo and the terminology and the training that we're approaching developers with is kind of confusing them. Every developer has a linter in their ID. Go talk to who's developed here and has a developer linter running, right? Most people have development linters running. Just tell them this is a security linter. It's helping us with code quality problems. They'll listen, trust me. If you message it like that, SAST, static application security testing. What does that mean to them, right? Nothing. And then you add DAST and IAST and SCA. These are terms they shouldn't care about. So what we started doing with customers is a development enablement program. Let's go enable developers and help them understand what we're doing in the lingo that they use to talk about their craft, right? I think product managers do a fantastic job at this, of being able to translate between developers and business. I think every AppSec team needs to think about like a product manager translating what security means truly to the dev, right? I don't have ending slides, unfortunately, so my talk is over. Do you folks have any questions or thoughts? Does this resonate? Does this miss the mark? I'm curious to see where everyone is kind of in thinking. So I feel like you have something to say. I'm going to bring the mic. I'm going to pick you because I know you.
Well, you probably know what question I'm going to
Ask.
So.
Oh, it's off, I think.
Also, I need to change your.
Oh. Test. Oh, yeah. There you go. Here you go. Sorry.
Oh, you can keep that.
Oh, I'll just use the mic.
Okay, gotcha.
Roving reporter. I think the one area of concern I have with this is it's all about detection, not avoidance. So how do we move it into avoidance so developers are creating good code, quality code, not creating code and then having to fix quality later?
So I love this question. I think okay. It requires, what I've noticed, great security teams that have excellence have a lot of might in the organization to actually do paved roads and secure by design implementations. And it requires a really strong alignment between CTO and the security team. And you actually need to hire security teams that are highly technical that can actually build these paved roads and secure by design implementations and have a lot of might in the design review process, right? If you have that, you will be able to get to excellence. What I'm talking about is getting to baseline. These types of issues like an SQL injection and path traversal and cross-site scripting, you can do a lot of that. The question is the juice worth the effort, squeeze at that point with what you're trying to secure, right? You have to make a choice. What are you trying to secure and what for? Certain frameworks are great choices that avoid a lot of these problems, but they expose other problems. So I think it's about working with architects who are extremely smart, working with security teams, working with engineers to figure out where you're going to have a lot of this, regardless of what you do. This is just going to always exist as a problem. But you can avoid the really big systematic things that get you breached with all these types of things. So I'm not talking about excellence. I actually view this as a baseline problem. Is that okay?
I agree with what you're saying about this for approaching the problem now, but I think, as Matt was saying, you know, if we're looking at moving forward, we need to look at, instead of training developers how to code and then train them about security, way early, first time hands on keyboard, I don't care how old you are, 6 or 20, code correctly. Not code and security. They're not two separate things. And when you talk about architecture or secure design, who has secure architects or architects that understand security? Again, that has to be already embedded so that future generations aren't even looking at this. I shouldn't even have a job. If we have developers who just learned how to code correctly, then this is not a problem. So we have to approach the problem now, but we also have to be looking at the future. How are we going to address this in the future so it's not a future problem or an ongoing problem?
So I hear this point, and it is a very rational point. And I agree with it. You still have to train, you still have to learn, you still have to avoid things. I'll be very honest. I am become a human SaaS scanner, unfortunately, because I've reviewed so many SaaS reports. I can look at some code and be like, oh, that's path traversal and stuff like that really quickly. I code to the day in our product, and I have made security mistakes. Because the unfortunate thing is when you're in the flow of development and you're looking at your ticket, you're just trying to get the functionality to work and to run. And I don't know how to explain it, but the intellectual control to actually encapsulate all of the considerations that I have to think about performance and security and bugs and exception handling, there's a lot.
There is a lot, and I grant that, but it's the same, you know, just like your example about, you know, this is obviously a test case, but what happens when they accidentally push that to prod? It's still a problem.
Well, that example isn't. As a test case, it's fine actually to have hard-coded credentials in the test case because, yeah, in the test case, correct. Yeah. Now, doing that mistake in business logic, that's a no-no.
Right.
Which is why you have the scanners that catch it. Yeah.
So we would still have scanners. We would
Correct.
still be looking for that, but if we are still starting with, don't just learn how to code and, you know, but that's the only thing you're thinking of, you still should be thinking about security as you're learning to code. It
100.
doesn't mean you'll always, that you're going to be a perfect developer. There's no such thing. I am not a perfect developer. You're not a perfect developer.
Correct.
There's no such thing. And there's never going to be, but we're not perfect security people either.
Correct.
So, but working together, we can both get better.
100%. I think that what we're saying is secure code training, and we're actually forming partnerships with security training organizations because we believe in that value. Look, we're up-leveling the machines to do this. Let's up-level the humans too. I completely agree. Humans need to be up-leveled. And I think frameworks are getting better and a lot of things are getting better, right? And I think this will happen. It's not a question of we will never see this continue to happen. I think this is going to happen, and actually at an exponential rate. We're going to trust code gen more. And as we trust code gen more, there's going to be an exponential uptick in code generation. And I worry about also the non-developers that are coding now, right? And how you instruct them, and how a developer might prompt something that actually is malicious now. And they review it really quick. Oh, this looks fine. Yeah, ship it, right? Oh, you got a question?
So do you have any insights into what are the low-hanging fruits to make it less shift-left, or make it more shift-left better? Like you told one technique, right? Like secured linters. Have a management approach when security is go as a management approach and change your messaging. I like that. What are the other, low-hanging fruits that you have for security folks to do that?
I've heard, so the messaging piece, I think by far, and how you talk to developers is like the biggest thing. I think the other thing that I've seen go very well is like ongoing, vulnerability remediation, but also campaigns. like running campaigns like, hey guys, we're gonna make this week's topic or this month's topic about SQL injection. Here's all the SQL injection findings. How do we go fix them? Here's how you do it here, 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 and here, here, examples around this. So you make it around a manageable topic rather than everything about security, right? And so I've seen teams, what they'll do is they'll prioritize their highest vulnerability count and have a campaign around it. And so what they'll do, the security team will go to the engineering team and say, look, if we build a paved road for this or a method or an implementation for this, we could probably wipe away 50, 100, 200 of these SQL injection vulnerabilities, right? And knock them away. So kind of to Matt's point and like some of the choices that you can make around campaigns and building some of these paved roads over time, I think can help reduce it and start to control and stop the bleeding, right? I'll let the cat out of the bag. We're actually introducing something around this with our policy center. So we're gonna allow people to define a policy on fixing so that when we generate the fix, it conforms to the policy, and that could be a paved road. It could be an actual secure implementation already with a middleware that you've built. So that now it standardizes across the engineering team. And I like this concept because now you're actually not about remediating a single vulnerability, but you now think about a class of problems. And when you start to think about things as a class of problems, you start to think about them as systematic solutions. And when you start to think about it as systematic solutions, you get better buy-in because they can focus on one or two things at a time. And I used SQL injection as an example. It could be an MFA implementation. It could be many other things, but you know, SQL injection is everyone's favorite, you know, Bobby drop table stuff. And yeah. Is that a good answer to your question?
Can you expand on the paved road?
Yeah, so it's a term I think the Netflix team pioneered, if I'm not mistaken, where you put guardrails and you pave the road. So we had a customer, for example, they implemented a middleware for XSS that takes care of all the kind of shitty parts of the library and kind of make it very simple for developers. You just drop this in your kind of controller and it takes care of everything for you. So the engineers built this and they created this middleware or custom function, I can't remember what it was, and they would just drop it in there at any point in time. Another paved road is you make things secure by default rather than secure by opt-in. So like I think frameworks like Django already do a great job of that with their ORM. Or for example, like that CSRF exempt is a forced opt-out of security. You're like, I'm now having to make a decision to actually remove this, right? So I like the term paved roads or secure by design. I think they're used interchangeably. Is there a difference between them? Sort of, yes. Do you want to educate us on the difference?
Well, I'll try. And then I'm sure I won't get it right, but or others, but I'm sure have other views. But secure by design is that what you design comes out about secure. Paved roads is that you're enabling the capability for somebody to be secure out of the box or have capabilities to have security. A good example here might be something like, so C is hard to get right. But with safe libraries that take the choice out of the developer's hands, but developers should have the responsibility if they choose technologies to do it correctly. We saw a lot of the missing code blocks that were up there should have been there. But if you build a paved road where those code blocks exist and the developers have to basically go out of their way to undo it, then they get a paved road to security.
That was a good explanation.
Yeah. Thank you, Matt. Oh.
I like your concept of security lint, and you mentioned AI-assisted fixes. Do you see AI becoming more prevalent in reducing the false positives from scanners?
I didn't pay him any money to ask this question. Just for context. So we do that today. So we connect to existing SaaS scanners, we roughly reduce 30% of false positives. And we've seen a really good level of success in its accuracy. It's immensely impressive because LLMs are extremely, extremely, extremely good at synthesis and context. Because what they're doing is they're using those keywords in your code to predict the next keywords, right? And so it actually can, like all of these things that I showed earlier on false positives were actually from our own product. And these are actual screenshots where we've detected these false positives. These are all LLM based. They do a fantastic job of it, and it's getting better literally day over day, week over week, month over month. And to go back to the crumple zones example, we're now replacing the humans with AI as the crumple zone. The AI will take the brute force of the findings, triage them, and now help assist these things. So you'll start to see developers with way less noise and just a little bit happier and less grumpy about security. Does that answer your question? Yeah. Now, do we detect every false positive? No. There's obviously more complicated stuff that we're trying to figure out. So like, I'll give you a perfect example of this, was like, you might have a vulnerability identified as an XSS issue in your controller, right? But actually you're sanitizing the outputs in the view. You're somewhere else in the view or maybe upstream, right? So we're starting to get into that world of being able to tentacle through all these paths and see where's inheritance and source and sync type stuff. Even the source and sync type stuff is a little controversial in my mind, but yeah, it will start to get there as you start to do that kind of stuff. What's interesting about LLMs as well in particular, actually this is actually a topic I don't think anyone's really talked about that I really like, is most of the source sync stuff is actually monolanguage. And what I mean by that is, or CPGs are monolanguage, which means it only understands one source and sync within the language. So why I'm doing this is, for example, I'm very familiar with Django. You're starting in Python, but you could be actually sanitizing thing in an HTML file. It's labeled as HTML. And you can't actually, most CPGs don't actually do that language conversion to actually say, oh, and here's how it converted into this language. LLMs are indiscriminate of that. So the LLM can go from here to here to here without really having to convert that concept. If you've ever used an LLM to you can tell it, oh, I'm going to talk to you in English and respond back in Spanish, right? It does that very easily. And so we have a theory that LLMs are going to be very good at traversing code bases through multiple languages, because sometimes you might have a JavaScript file, followed by a Python file, followed by an HTML file. And so we want to see how we can weave through all of them.
So on one hand, we're saying we need to educate developers and we need to kind of close that gap and educate earlier. On the other hand, we're saying, you have a hard-coded password, we're not going to flag it, sure, because of the context, but then, me as a new developer, isn't the gap not going to get bigger as to, because of the context of the application, we're not going to flag a SQL, you're doing your SQLs all over the place from a security perspective, but we're not flagging it because it's not, where's your view on that? I remember you're just going to get further and further from the developers on that, education-wise?
I don't think I understand the question completely. Are you asking
Not flagging it in test cases or in code A and flagging in code B, would a developer be confused? Now, should I write this by default with encrypted password or without encrypted?
So you have two choices. You either suppress all the false positives from the dev team, which is a valid one, and the security team reviews the false positives because that's a smaller cohort now, and the security team can actually review them. Or you leave it to the developers. Hey, your SAS, because they might go back to the SAS scanner, or they might get a Jira ticket from the SAS scanner, or they're looking at some Jira ticket that was opened, a year ago they now got to, right? And so telling them it's a false positive with an explanation can help them be like, okay, we can close this off. So it's choices depending on how the developers kind of understand it. I don't have a strong stance about it. The one I like is to suppress it from the developers and let them see the valid findings only, and the security team handles the false positives and then decides, okay, whether or not we want to let it go. And I actually have a really good example in our demo environment. If anyone's interested, come to our booth, where I actually show 60 false positive SQL injections with one valid one in the middle. And everyone's like, Why is this one valid and all these 60 are false positive? It's because you're actually not parameterizing in this one valid one, but all of them you are. So I don't want to create another alert fatigue. So which is why I say suppress the false positives and give the developers only the valid ones to look after. Is that a good answer? What do you guys think about that kind of approach? Would you guys do something similar at your companies? I'm getting my miles in.
We do something similar, but what we do is we have a confidence rating. So for the ones that have been validated by the security team, we kind of say that, but we say with high confidence. And what we do is we aggregate the ones that aren't, and we sort of expose them in a different way and ask developers, could you, if you have time, tell us, does that look right? And they're sort of optional. And what's really great is developers love telling the security team things that they don't know. So it works really well.
I like that a lot. I like that a lot. And are you doing your confidence rating on the vulnerability or the asset?
The vulnerability, to a certain extent, we do talk with the asset, but mostly.
I have a really cool idea I really want to implement. I don't have the dev power yet to do it. We want LLMs to auto-label your assets as crown jewels or not, because that prioritization problem, like I'll give you an example. SQL injection in your like currency microservice, no one gives a shit about. Breach it any day, it just has currencies, right? Or if this is handling my payments microservice, this is a big problem, right? And I think we think about, unfortunately, like the prioritization problem as a vulnerability problem rather than an asset problem. And the reason I ask that is I know the DigitalOcean team did a big exercise around how to prioritize and affect the ratings based on the asset that it's found in, with the context of what they're doing. I thought that was a really cool like concept, and I think I can go on about this, so I'll stop here. Any other questions or thoughts or?
I'm curious how we keep security champions from becoming the next crumple zone.
Actually, I'm going to add that now to the slide. That's a pretty good one. I think they're a crumple zone by design, right? Unfortunately. And I think they opt in to be the crumple zone by design, which is funny now that I think about it. I think when you have assistive tools with the security champions that can help navigate these things, I think it's good. But I think they are crumple zones without any of this, right? You're correct. Like, it's just another human in the loop, unfortunately, that's just getting crushed by these requirements and are expected to be the security voice within the room, right? I don't have an answer for that. I mean, ultimately, it's like, yeah, it's just who are you pointing the gun at with the scanner? And the security champion might be one, the dev manager might be one, the engineers might be one, the security team might be one, right? So it's a valid concern. I would have loved, I don't know if you know Dustin Lear, who does a lot of the security champions. I would have loved for him to be in this room, and I'm going to ask him this question, because I would have loved to see what he thinks about it. Q, you had a question?
It was more so just a thought. I've heard the conversation since I've come in. And as a person who started off lightly as a developer and who is a full-time application security engineer now, I've been on both ends of the fence. And I would say, I think what will help, and this is fully opinionated as well, by the way, but I feel as if one thing that could help the relationship that is strayed sometimes between developers and security engineers, if you will, is if we all begin to develop an understanding that humans, us ourselves, are always going to be considered, in the security world at least, the biggest SPOF, the biggest single point of failure, just because we are prone to simple mistakes, because we're humans. We're all human. And it's not one of the things where it's like give all the ability and the innate capability to a tool and it'll fix everything. It's if, one, we begin to utilize these things in the nature of what they're supposed to be used to help us, assist us, whatever the case may be, as well as see the relationship between that security engineer and the developer as a more so symbiotic situation, more than just, hey, look, for lack of better terms, this baby you have in your code is completely wrong. Nobody wants to hear that. Nobody wants to hear that, right? And from the developer end, okay, you're doing something else to throw another monkey wrench in there to mess with my functionality, mess with my processing speeds, anything of that nature. It's not really coming from a place of malice. It's more so, this can help me help you on both ends of the fence. Whereas from the top to the bottom, if there's less of a distasteful relationship between the two parties, because once again, it's not always malicious, which we're all human. Once again, people can go about that education incorrectly. If we all just decide that it can be more of a symbiotic thing, that it could help us over time. Because yes, there is, I think we all understand that relationship can get a little testy at times, but it's more so of a let me help myself help you type of thing, as I've been on both ends of the fence. And I've been told, hey, yeah, this is incorrect. This was created incorrectly, insecurely. And I'm like, well, if I do what you're telling me to do, this is going to either completely break, the speed is going to be bad, anything of that nature. And now that I am the security engineer, I can definitely understand that that person wasn't coming at me with malice. It was more so like, this can be a very huge problem if it isn't fixed. But there, once again, if you guys can help educate those security engineers on things that they might not be aware of, and vice versa, it can help.
I actually like this point a lot. When I was the director of product for the payments team, I used to go to the security team to get an approval without them asking for the need of an approval. So I used to get their buy-in around things that I knew were sensitive. And payments, who's ever worked in payments? Yeah, I see. It's like the seedy underbelly of the finance world. Like billions and trillions of dollars are literally moving over flat file SFTP. Like, I'm not even joking. That's the reality of the payments world. And we were moving billions of dollars. So when we had a design that I thought was sensitive, I would send my PMs to schedule a meeting with the security team. The security team would find out about this. They never knew about it because they're trying to like cover all these people. And we would go to them, educate them about why this was important, and if our thinking about it was correct. One of the really big features we developed was a second RBAC within Coupa, because we had a fear of an omnipotent admin hijacking and making payments. Right? We were like, we can't have the admin have super user access, because they could like literally initiate a payment. And these like Coupa customers are like Amazon and some of the world's largest companies, and these are connected to bank accounts. So we were like, let's create a secondary RBAC where it always required two people to conspire to commit fraud with the company. And we went through multiple sessions with the security team. We understand payments very well. They understand social engineering very well. They understand phishing attempts very well. They understand RBAC very well. And so we partnered with them to create this secondary RBAC. We even got to the point that we required the customer to send us their ID, secured it for PII, to verify the person who says they're an authority in finance to actually grant these to grant the people access to make payments. And it was usually either the CFO or the controller, because we couldn't trust the person in the implementation to tell us who they were. Yeah, just give me access. Yeah. No, we need the signing authority of this company to actually do that. Every customer was like, oh, this is friction, and then we explained to them, and they're like, oh, you're protecting my interest. This wasn't about the security of our platform. This was we didn't trust the customer's security, because what would happen if the customer's emails got compromised? I've seen countless incidents of people losing their money over poor email practices and phishing attempts and all this stuff. I've seen a phishing attempt in payments where the fraudster impersonated both sides of the house, both the payer and the supplier. It was so sophisticated. It took months to figure out what happened, right? And so we force customers to follow our standards in payments. And we said, your bank asks you to do all this, we're going to ask you for the same thing because it's just an extension of your bank. And that's where I think, to go back to your point, it's the marriage between security champions who can be that voice to go to security and work with security to figure out how do you actually get customers to succeed. Because at the end of the day, we all want to succeed, right? But how do we join that marriage together, right? Any other questions, comments? By the way, who here was a developer in their past life? Or who has written, oh yeah, okay. Is still a developer? Yeah, okay, still developer. Actually, two, three, 4, 5, okay.
I'm an architect, so I dabble.
You dabble?
And then I hand it off.
Do any of the developers have any commentary about this as well, or thoughts?
I sort of have one question. So I won't say where I work, but if I'm in the middle of vulnerability hell now, dealing with a security team that wants to use a tool to throw vulnerabilities at my team, with a manager who insists you must fix all vulnerabilities and it's possible to get to 0, and won't listen to my suggestions that you can't get to 0, because by and far the most vulnerabilities we see as developers are unpatched library or library out of date. So every quarter I can make my team go in, update like my Spring Boot libraries to the latest version. And then the scanning tool will come right back through, find the same vulnerability again if it's in one of the lower parts of the framework and it needs a very specific scenario to actually exploit it. It's not really a problem, in my developer opinion, right? But the SaaS tool just goes, vulnerability, comes back again. So they don't really buy me saying, look, you can't get this to 0, right? You can get this manageable, you can knock it down, right? You can make sure you've got no giant problems that are going to cause an issue for the company, but it's never a list that's going to get to 0, at least in my opinion. Are there good ways to convince security of this?
Yeah, I think there's a couple. So we as a company have always decided security hygiene was just very important from day one, and this is a hygiene problem, right? And unfortunately, if you haven't had good hygiene, you rack up a lot of these and it becomes a mountain to climb, and that's hell, right? And so I think for any new microservices or any new services that are getting kicked off, just the hygiene needs to constantly be on top of it. I think this also comes down to, I actually have a risk management background, taking a risk management based approach. I think there are great tools out there that already help weed out the noise, like our friends at Endor Labs. They do a great job. Reachability, they look at the code paths and they say, this is actually just noise, you don't even need to care about this, right? I think it's a hygiene question and a tools and process. Like, let me say this. We're a tool. We're not a silver bullet. What I think most security teams get wrong is they buy a tool thinking it's running a program. And what I think needs to happen is a program is people, processes, policies, and a tool together. And I think it really is contextual around what the company is going through, their vulnerability backlog, what all of that combines, because having an SLA to just auto-remediate or remediate everything, in my opinion, I'll tell our customers, that's kind of dumb. Like, honestly, are you gonna go like fix all of your header policies or fix every low like thing? The other flip side to it is, do you wanna have debates about all of them? Sometimes like it's just easier to fix the thing than debate it. I don't have a good answer for this. Does anyone in the room have a good answer for this where they've seen it? Yeah.
I don't know if it's a good answer. It's our answer. We had that same situation as you described. So what we did was when we saw things keep coming back and we know that they weren't really problems, we kind of tried to satisfy everyone. We satisfied the security folks by saying, let's not get rid of them, but let's make them queryable later in case we want to go looking. And then we sort of hid them away with a note saying, we have hidden this because of it keeps coming back and it's not valid. And then we said, every quarter, I think it is, we will go back and look at it to do our due diligence. And that kind of was the balance, because it made it so that they weren't ignored, but they weren't like always coming back, because that just pissed everyone off.
I like that. I know what you think about it. I like that a lot because it satisfies compliance. You have a record of it. You have a record someone reviewed it. You have a record of a decision, right? I like that a lot because I think that's really important for a lot of the stuff that's coming out, especially if you're HIPAA compliant or FedRAMP compliant or PCI or the likes. I think it's cool because you come back to it and review it. I think it's not like, yeah, You know, I remember as a PM, my favorite thing was like, won't fix. And then it goes into this ether of JIRA tickets, won't fix, and never gets reviewed. But I think with security, you can't do that ether of won't fix, because also code context changes. What wasn't exploitable 6 months ago might be exploitable now. Someone exposes an endpoint or uses a function in a third-party package. Context is everything again, right? And that context is a moving target, right? Developers are shipping code. So I like the fact that you're reviewing. I don't know what you think about it, if that helps you.
No, it sounds pretty good, right? I mean, you've got to be able to like put things away and know that, you know, take them off the list, make the list shorter, right? And actually get to the things that might be a problem, right? But like you said, you've got to be able to review them at certain periods in time because things become exploitable that weren't, right? Seems decent.
I think that's part of the program. It's a process, and you dedicated a process. I think that's pretty good. Any other questions or thoughts? I think we're up on time, right? Yeah. Okay. Well, thank you so much, everyone. Really appreciate it.